Hello everyone, today we are going to learn the trick to calculate bond order. So without any further delay, let's dive straight into the video. Before directly moving on to the trick, let's find out the actual way of calculating bond order. Bond order is represented or written as BO and its formula is half of NB minus NA. Here, NB represents number of bonding electrons and Na represents number of anti-bonding electrons. So now, the question arises, how to find Nb and Na, that is, the number of bonding electrons and the number of anti-bonding electrons. So if the total number of electrons is less than or equal to 14, then electrons will be filled in the order of sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px is equals to pi 2py, sigma 2pz, pi star 2px is equals to pi star 2py, and sigma star 2pz. Here you may notice that there are certain terms where star is present and there are some where star isn't present. So the one which contains star in them will have antibonding electrons, and those terms where star is absent will have the bonding electrons. So now what if the total number of electrons is more than 14? In such case, the electrons get filled in a different order, which is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz, pi 2px is equals to pi 2py, pi star 2px is equals to pi star 2py, and sigma star 2pz. Here you may notice that there is a slight difference when the total number of electrons is less than 14 and when the total number of electrons is more than 14. Since in both the cases the order of filling the electrons from sigma 1s to sigma star 2s is same, so it shouldn't be difficult for you to remember it. But what comes after may be an issue for you. So if the total number of electrons is less than or equal to 14, then you should follow the order 2 1 2 1, and if the total number of electrons is more than 14, then you should follow the order 1 2 2 1. 1 because there is just one term present in case of sigma 2pz or sigma star 2pz, whereas 2 in case of pi 2px is equals to pi 2py or pi star 2px is equals to pi star 2py, as there are two terms present in it. Also remember that the term containing bonding electrons always comes prior to the term containing antibonding electrons. In layman term, if the electron is above 14, follow 1 2 2 1, and below 14 then follow 2 1 2 1. So now let's move ahead and find the bond order of O2. Since the total number of electrons is 16, that is more than 14, the order of filling electrons will be sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz, pi 2px is equals to pi 2py, pi star 2px is equals to pi star 2py, and then at last sigma star 2pz. Each term will have 2 electrons and there are 16 electrons in total over here, so electrons will be filled till pi star 2px. As the formula of calculating bond order is half of Nb minus Na, and Nb over here is 10 and Na over here is 6, so the formula would be half into 10 minus 6, that is 4 by 2, which is equals to 2. So now let's move to the trick that you all have been waiting for, which is the trick to calculate the bond order in less than 10 seconds. All you have to do is to write 1 0, 1 0, 1 2, 3 2 and 1 0. And below each digit you have to write 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. You can also remember the upper part by 10, 10, 12, 32 and 10. The number mentioned above, that is the 10, 10, 12, 32, 10 represents the bond order, and the number present below, that is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 represents the total number of electrons. For example, if the total number of electrons is 6, then the bond order is 1, and if the total number of electrons is 16, then its bond order will be 2. Also, if the total number of electron is an odd number, for example 13, then the chances are its bond order will lie between 2 and 3, that is 2.5. Now let's verify it with the question that we have previously done, which is calculating the bond order of O2. As in O2, the total number of electrons is 16 and the bond order is 2. This indicates that our trick is accurate. Though this trick would be helpful for you and reduce your time for calculating the bond order, but still there is an exception that you have to keep in mind, which is the bond order of CO+. If you calculate the bond order of CO, it comes out to be 3, and the bond order of CO+ comes out to be 2.5. But 2.5 is not the correct answer. The correct bond order of CO+ is 3.5. This is an important exception that you have to remember. The total number of electrons present in CO+ is 6 plus 8 minus 1, that is 13. It doesn't matter how you calculate the bond order, whether it's by using the trick or by using the formula. Since the total number of electrons is less than 14, you have to follow the 2-1-2-1 order, which will lead you back to the bond order 2.5, but that is wrong and 3.5 is the correct answer. Always be aware of that. Now, before ending the video, let's have a look at certain bond parameters. Remember that bond order is inversely proportional to bond length. That is, if the bond length increases, it means that the bond order decreases, and bond order is directly proportional to bond energy or bond dissociation energy, which means if the bond energy increases, the bond order increases. Also, bond order is directly proportional to stability. So, more is the bond order, more is the stability. But if there are two compounds given, each having the same bond order, then the stability is inversely proportional to the number of antibonding electrons, which means more is the number of the antibonding electrons, less will be its stability. With that, it's a wrap. Thanks for watching and feel free to mention your doubts in the comment section below.